Hi everyone. Welcome to BootXP. All right, hi everyone. Welcome to this call. Um, this is BootXP, the data analysis track organized by MLSA FUNAAB. On this call, I want you to take note of our code of conduct. We urge you to be welcoming and respectful. We want you to be aware of others, to be open to all questions and viewpoints, the understanding of differences, be friendly and patient, be kind and considerate to others, or someone is trying to join the call. Um, let me see. One wants to join. All right, all right. So on this call, please be welcoming. Sorry, please be friendly and patient. Be kind and considerate to others, and for the audience guidance. Please use the raise hand to ask the question. Question in chat prefixed with Q column. Use the at mentioned to respond to an individual. Return to mute when not speaking. Use all text for images and GIFs. Then you could use the massive reader. It can be found by clicking the three dots um, in the meeting chat. All right. Officially again, welcome to BootXP. Again, this is the data analysis track, and we'll be considering the theme or the topic introduction to data analysis with the subtitle understanding the fundamentals of data in the modern world. All right, without further ado, let's get to today's agenda. So what would you learn today? Well, you'll learn about what data is, you learn about the types of data, you would learn about the importance and application of data, you learn about descriptive statistics, you learn about visualization, you learn about data analysis tools, you learn about data analysis workflow, and storytelling with data. All right, so what is data, right? Um, this is a quote from one of the people I look up to. Is yeah, more like a mentor. He would say, or he used to say that data is the new oil, and I live in an oil country where nobody's drilling, right? Oyiboke, Layo Oyiboke. So, yeah, data is the new oil, and we live in the world, right? We live in the world where, well, not like, well, okay, let's narrow it down. We live in a in an oil country where nobody's drilling. All right. So obviously that was not the definition of data, like the official definition of data. But I feel like it makes sense to talk about that code because it makes sense right in Nigeria. And maybe later on, it will really make sense when we get into the presentation. All right, so officially, what is data, right? So data is the collection of facts, figures, observations, or measurements that can be recorded and analyzed. Examples of data in everyday life. Um, One example would be student grades, right? Maybe just as when students sit for any exams or tests, their grade gets um, combined or compiled and is being sent or printed or posted on the platform or portal or any kind of means. But you get the idea. You have student grades, right, in from a particular test. So another example could be say temperature reading, right, of let's say a room, maybe over time, or yeah, it could be interval of let's say a day or even hours or minutes, right? And we have several examples of data, right? I can go on and on talking about examples like would have medical data about let's say um height, weight, and all of that, or data around maybe yeah, strong health data around maybe tendency, okay, maybe measuring heartbeats and all of this stuff. So we have a lot. You could have data sets on concerning climate. You could have data sets around um just trying to, but you get the idea. We have different kind of data. It's a lot, and probably any, well, depending on where you're coming from. Okay, I just remembered one now, and I'm going to just talk about it. So let's say crop yield and um the climate condition, right? Or let's say student age and maybe their performance, or including maybe their yeah, maybe their study hour and stuff like that. We get, so we could really have a lot of options, and maybe for stuff like nations and their population or birth rates, death rates, those kind of stuff. So the list goes on and on. All right, so the next thing is structured versus unstructured data. You would most likely hear about this term, structured data, unstructured data. So I think it's very nice to talk about it, right? So what is structured data? Structured data is organized and easily searchable, like information in table format. Most times they are in table format, and examples of this would include a spreadsheet, databases, or the popularly known CSV files. Then the unstructured data, um, they lack a predefined format, and they can be more challenging to analyze. Yeah, they are very most times very complex or difficult to analyze. And examples include pictures, videos, email, or text. Imagine you having some pictures, images that you want to extract data from. So you probably have to go through it manually, manually typing in the whatsoever data you have, or um, leveraging AI, maybe using OCR to automatically read those maybe data points, and just get it into whatever format you want to, spreadsheet, CSV, CSV, or the likes. So you could see that it's either, well, you get the option. It's either you have to do it manually, which is time consuming and less efficient because you could make mistakes, or leverage on AI. So it just has another layer of work to be done, right? It makes it quite complex and challenging. All right. So um, a large amount of data is generated every day. From this chart, we see that every minute of the day, TikTok, you might not be able to see this clearly. Even I am really struggling to see it now, but you get the slide. Hopefully, I'll be able to get the slide across to you. So when you get the slide, you can just get a better look. All right. So from here we see that sorry, just a sec. All right. So TikTok users upload 16,000 videos. Remember, in a day, every minute of the day, right? So that's the time frame we're looking at now. Every minute of the day, TikTok users upload 16,000 images. Netflix subscribers stream 362,962 hours People do 5.9 million Google searches. Three answers 1 million plus questions. Um, 18.8 million text messages are sent. Um, 3,472,222 YouTube videos views. You can just continue and check uh through the chat, but you get you get the point. Um, a very big chunk, I shouldn't say chunk, like a very big size of data is being generated um every minute of the day, and up to us to figure out what we do with this data, how we use them, and the kind of changes or the insights we could bring from them. And to the left, to the right of that chart, we have another chart which shows the global internet population growth. So that tells us that in 2014, about three in billion, so 3 billion people use the internet. Then fast forward to 2018, 4.3 people uses the internet or use the internet rather. Then to 2020, we have 4.5 billion people use the internet, and 2024, which was just last year, as at the time of this analysis and chart, um, 5.5 billion people use the internet. So data never sleeps, right? So if you want to look more into that chart and read more about it, you could click on the link there and read more about data never sleeps. But it is interesting to see that there is this big size of data being generated. For another interesting thing, I think, is what are the types of data, right? So we'll talk about the types of data, and majorly we have two categories, or two types that I'll be looking at. Um, that qualitative data, which basically means categorical, like we'll explain that when we get well, in a few minutes. So we have qualitative data from the word qualitative. If you remember, um, back in primary school, primary nursery school, when we do uh qualitative, quantitative, and qualitative, verbal reasoning, and quantitative. Quantitative has to do with math, right? And why verbal reasoning has to do with some oral reasoning, sort of. So you can use that same idea to wrap your mind around this thing. So qualitative has to do with not numbers. In this, to make more sense, you can say categorical. Why? Okay, we'll just talk about when we get there. So, the qualitative data are subdivided into two categories. We have the nominal, which means that no order is involved, right? For example, we have gender, or we have colors. Let's take for instance, we have male and female. There is no order per se. I know if you want to be gender biased, you say, well, men is greater than, like males are greater than female, but that's not right technically, because there is no order to this thing. Or okay, maybe I should use the color example just to, well, certainly with gender, there's no order except if that's defined, but um, primarily there is no order between a male and a female. I know some culture and all would give that um male, or yeah, male are more dominant, or should have this higher rank than women, but that's not that's not completely true. So I'll just take the color example so as not to complicate it. So assuming we let's take for instance we have red, yellow, and green, and I'm to select from these colors, right? There is no order per se. You get what I'm trying to point out? What I mean, what all the nominal just means is that there is no order, no arrangement, no kind of there is no, you could say priority, but I feel like the right word is order. No order involved. Whether this comes first or this comes last does not count. Does not affect the, does not make any difference, right? Why the other one is ordinal? In ordinal, other matters like their ordered categories. Take for instance, educational level. Let's say we have okay, someone who has primary education, he has a lower rank than someone who has secondary school education, and someone who has secondary school education is lower in rank to someone who has tertiary education, right? So you get the point. There is order to ordinal. There is no order to nominal data. And that leads us to the second category, which is quantitative data. Quantitative data, just like quantitative reasoning, right, just talks about numerical data, and they are subdivided into categories also. So we have discrete. And discrete just means that they are countable, right? For instance, we could have number of students who attend a school, or say number of students who pass a course, or number of cars at a park, or just the options are endless now, right? So the idea is that you can count, it is countable. So that makes it discrete. And the other one is continuous. For continuous, they cannot be counted, but you could measure them. And examples would be your height, your weight, right? You cannot really count height. You can't count how much I weigh, but you could measure it, right? Using a meter rule, or for the height, and a scale for the weight, right? So um, quantitative data and numerical, discrete data are countable, continuous data are measurable and not countable. All right. So what are the importance of data? Right. So the very first example, importance I have here is that with data, or from data, you could make informed decisions. Organizations rely on data to make strategic decisions, right? And not just organizations. I mean, these days, even I as an individual, you as an individual, you could collect some data around your life, um, focused on some variables, of course, and you could make strategic decisions from this data, right? So not just uh, organizations, even individuals, small businesses, firms, and all can rely on data to make strategic decisions. And another point is that is policy and planning. Yeah, government, obviously not just government, like I said, individuals, small businesses, and organizations also use data for budgeting and development, right? Then another point is innovation. Data drives product development, automation, and discovery. And lastly, accountability. So with data comes transparency. Yeah, transparency in performance metrics. So you can't just bring things to me. You can't just cook things up, because there is data, that there is transparency, because um if you bring your results, I should be able to, I should be able to work it out, right? Because I also have the data, and you should tally, right? Right, so those are obviously not all the importance of data, but those are just the ones I feel like the- I selected to talk about. And moving on, we have application and uses of data. And the first one I have here, well, in business, um, customer behavior analysis, like data could help customer behavior analysis. Data could help or make sales forecasting possible. And in healthcare, diagnosing diseases is possible with data, or data makes diagnosing diseases possible, and also tracking outbreak. Like if you remember, during COVID-19 breakout, the data, constant data about number of people, sorry, the number of people that were affected, the number of people that recovered, the number of people that died through as a result of the virus and all of that. So in education system, data makes student performance tracking possible. In finance, it makes data makes credit scoring and fraud detection possible. In agriculture, data makes crop monitoring crop health possible, and it also makes yield crop yield prediction possible. And in sports, data makes player performance analysis possible. So again, these are not just the applications and uses we have, but these are just the few I've selected to talk about. All right, moving forward, we will talk a bit about descriptive statistics. And for this introductory class, I feel like I don't want to bore you guys with equations and formulas. But ideally, you should have basic knowledge of mathematics. You should be comfortable with mathematics to venture into data science. That's my thought. I well, you might not really need that much, but at least I feel like you still need some. Yeah, obviously you need basic mathematics to thrive in data analysis world, right? Because underneath the wood, you are doing math, you are applying some mathematical concepts, and at least you should know what those concepts means and probably explaining them by or making sense of them because most times you run an analysis and you want to be able to interpret, right? Because you want to, yeah, you want to get the insight down to your stakeholder or your employer and all of that. So um my point is you need to be comfortable with basic math, but it's not like a whole lot of math. And another thing would be it will depend on um your level, probably the kind of data you work with, and yeah, kind of analysis you do also. All right. So the first thing we'll be talking about under descriptive statistics is measure of central tendency. Know you are um if you are taking a statistics course, even mathematics, or you're a student of statistics department, you would be conversant with these things. But again, looking at the data, looking at the response from the registration, we have some student, um, we have majorly students, we have some working class, and so I just did not want to make any assumption. I just feel like, well, I still did not go deep into it, so it's just like um short summary and just like straight to the point or key points of what these things mean. So completely fine, I guess. All right, so measure of central tendency, right? So the first thing here is mean, and what the mean just talks about is the average value, right? So if you have some set of values, you want to look for the average value. How do you do that? Remember from the formula of mean, you take the total of those set of numbers or values and divide by the number of those numbers, right? So the idea of mean is that you're trying to get the average value, or as someone would say, you're trying to get a representative of that of those values. Yeah, you're trying to get a representative of those values that is um not too high and not too low. Just want the medium, like the average, right? Average. So that's typically what the mean is. And the next thing is the median. And the median is just as simple as the middle value, right? The middle value. And mode, the mode is the most frequent value. So median is the middle value, mode is the most frequent value. Then move to measure of dispersion. So for measure of dispersion, we have a range. Range is the difference between the highest and the lowest value. Then we move to variance. Variance is the spread of values. Um, how how these values are distributed, so to say. Then we move to standard deviation. Standard deviation is the average distance from the mean. So what is the difference between each of these value, or what is the difference between these values and the average value? How how far away are they from the mean, or how close are they to the mean? So that's just what standard deviation talks about. And lastly, we have frequency distribution, which talks about how often the value occurs in the data set. Sounds like mode, right? Yeah, kind of. So it talks about how our values occur in the data set. You could see it as the distribution of the values, yeah, of set of values also. So how these values appears, um, yeah, how they appear. All right. So the next thing we'll be talking about is data visualization. All right. So what is data visualization? Well, data visualization is using charts to convey messages to the audience. And why, or what is the purpose of the data visualization? Why do we need to visualize data? Well, the purpose of data visualization is to simplify data interpretation through visuals. Um, it is, as human, our eyes love seeing. Well, okay, let me say that charts are appealing to us. Like we just kind of we kind of get the picture. Like when I showed the chart earlier about the global internet population growth, that was just like a trend of, well, it was an upward trend because the population keeps growing. But sometimes it might be hard for us to figure those things out looking at data points. So that is why we turn to visuals. We run to charts, and certainly we run to charts for visuals to help us present this finding a more appealing way to the end user, or in a way that they could just see and they understand clearly, not really having to do with the numbers, and yeah, not really having to do with the numbers. All right, so we have um different kind of charts. We'll be talking about the common charts. Right? These are likely charts you come across within data analysis. Obviously, there are more, but these ones are very, very common. Ideally, when I was making my slides, I just felt like everybody should know this chart. But at this point now, I'm feeling like, how sure am I that everyone knows this chart? Or maybe at some point I will just try to display this chart so we really see them. Yeah, I'll make sure I do that. I just try to not forget. So I will just display each of these charts. But for now, let's just talk about them. The first one here is bar chart. Like I said, I'll try to show this chart. In case you don't know them, it's totally fine. We'll go back to this again. So a bar chart is very good um for comparison. So if you are trying to compare things, you want to show comparison, you should, or you most likely come to the bar chart. Now, another chart is the pie chart. Pie chart is very good for proportions. And also we have line charts, like the kind of one we saw earlier. Um, is very good for showing trend over time, right? The global internet population growth we talked about is a line chart. Then we have histogram. Histogram is very good for showing data distribution. And we also have the last one here, the box plot. Box plot is very nice to show data spread and to spot, spot identify outliers. And what are outliers? Outliers are just extreme. extreme value or extreme data points in the data. It could be extremely high or big values, or extremely low or small values. So um, box plot is a very nice tool to spot those kind of values, and yeah, to spot them. All right, so obviously there's more to visualization, data visualization than this. And this is just like a quick intro, like just walking through this phase so that I don't assume, right? So that's the whole essence of this. But obviously, in the future, we'd still have sessions like completely devoted to data visualization. Probably would put some visuals together. We'll talk about more do's and don'ts, what you should consider, um, um why you should use charts, when you should not use charts. Like I said, even though I'm saying that, okay, for example, I'm saying that whenever you want to do comparison, you should check out the bar chart. There are times that you won't probably, or using bar chart will not be your choice. For instance, let's say um you have about 20 variables that you're trying to compare. Well, once it's greater, in fact, even 20, I feel like it's too high, because at that point, your bar chart already gets, oh, I'm already going ahead of my slide, but let me just talk about it because we are here already. So at that point, your bar chart is already clustered like with a lot of chart, and might be really confusing, or maybe not really clear to really read it. So ideally, I think the set condition is greater than 20. You should definitely not try to use uh sorry about that. I was away at talking to something. So yeah, I was trying to talk about, yeah, I was talking about bar chart. Like, you having 20 variables on the bar chart is already like clustered. You don't want to have that much. All right. So I was going to talk about do's and don'ts. Obviously, these are not the only do's and don'ts, but like I said, probably have more sections like focused on data visualization, and we'll talk more on that when we get there. But for now, for the do's, use clear labels. Make sure you're using clear labels. You should use labels. Like, I love using labels. I just feel like you should use labels basically. Like, just use labels. Then use appropriate charts. Like I was saying the other time, use this for comparison, for proportion and the like. So you know the right chart to use for the right situation, or for the right insight you are trying to convey. And um for the don't, you want to avoid cluster or clutter. Like I said, like, you don't want to have this um clouded charts without space, like without, there's something called white space in design. Yeah, you want to have that. Then um you don't want to use misleading scales also. Ideally, you should also like state your unit for scale when in your, like, the axis of your chart. All right, so tools for data analysis. Oh, sorry, tools for data analyst. There are several tools for a data analyst, or used by a data analyst. But I feel, so I just decided to talk about the ones I think will be using or considering through this course. And yeah, just limit it to those, to those. But obviously, there are way more than this. But these are the ones we would be considering. That is why I'm just going to focus on this. The very first one on my list here is Microsoft Excel. Yeah, Microsoft Excel is a very powerful tool, and I feel like it's like the most like the most fundamental tool um for anybody into data at all, because you keep getting CSVs, right? And maybe okay, that's just it. Microsoft Excel is a spreadsheet program. All right. So more about data analysis with Excel. Would still have sections using Excel, doing one or two projects with Excel, demonstrating Excel's power, like writing functions and all of those. So we'll see that in the future. All right, so the next thing here is SQL. Um, SQL stands for Structured Query Language. We might not be considering SQL, but maybe we might. So we might not, but we might. All right. So like I said, means structured query language, and it is just it is the language is it is a language for database. Yeah, it is a language for database for databases. All right. So up next, we have programming tools like programming languages, right? So here comes the popular Python, right? So we have Python, of course. You want to use libraries like pandas, like NumPy, Matplotlib, and many more for your analysis. So I'm sure, but let me say, I guess, or let's say 0.5%. Oh, yeah, 0.5, 50%. Um, I'm hoping that, okay, I am guessing that you must have heard about Python. Even if you don't use Python yet, you must or might have heard about Python. So, more sections like section focused on Python, in the future would introduce Python, do some basic Python programming, and then we narrow down to using Python for data analysis, because Python is a very vast programming language, but very, very nice and user friendly. All right, so up next is R. So R is a statistical computing language. All right. R is a statistical computing language with cool graphics, right? Yeah, I feel like yeah, R has really improved. I think one of the reasons why, well, I would have loved to ask how many people knows or have heard about R. I'm sure the population would uh perhaps be lower than people that have heard about Python. That's my guess too. I think Python is, well, though R is now becoming very, very, very popular, especially I think among academic, yeah, in the academic world. I feel like R is gaining much ground, and I think generally R is very, very growing, and R is growing rapidly. And another interesting thing is I feel like um people prefer Python because, well, that's not the only option. Perhaps, well, obviously not the only option. And my thoughts, yes. So because Python has more fancy and more interesting and amazing looking charts. But recently, you should check out our charts. I mean, they are very, very nice now. I mean, with ggplot2 and a whole lot of other libraries or packages out there. You could now even create interactive charts with R. So very, very interesting. Check that out. Like you could create I know of one package. animate. Yeah, you could check out animate and create interactive charts with R. Up next is our visualization tools. So for visualization tools, I have two here, which is Power BI and Tableau. But of course, we would be focusing on Power BI on this session. And again, more dedicated sessions on Power BI would be in the future. All right. Each tool serves different purposes depending on the complexity of the analysis. It's just like a note. Like there are some things that, well, maybe you might not even be able to do. Maybe I should not say you will not be able to do, but there are some things that are just easier done here than this. So you probably get to know all of those things when you start working on them or with them. All right, so up next, we are considering data analysis workflow. So for the data analysis workflow, oh sorry, the first thing, okay, so let me just talk a bit about workflow. And get let me not make any assumptions. So the idea of workflow is like the process you go through, like the cycle, yeah, the cycle you go through as a data analyst. That is what we're talking about. So the very first thing here is for you to define the objective, set your goals, and to do that you could ask questions like um so you would ask questions about what you ask questions what questions you are trying to answer. Like you ask yourself questions that you are hoping to get answers to at the end of your analysis or the end of the end of your analysis. That's the idea. So you set objective, and the next step is to collect data. Let's say my goal or my objective was to determine if um rainfall increases crop yield. Probably dumb example, but oh, sorry. But let's just take that as an instance. So my goal was to see if there is any um significant effect on crop yield if weather or climate condition as or rainfall, maybe to narrow down, rainfall has any effect on crop yield. So if that was my goal, then I collect data. Certainly, I need data around um, rainfall. I need data around crop yield. So I collect my data. To collect your data, you could use surveys, you could use APIs, you could use publicly available data sets, and yeah, just trying out. I think the best thing you could do is to use publicly available data set. You don't want to start well, depending on what you're doing, if it is like your project or something you just feel like would be nice for you to look into, well, then go ahead, quote surveys, and yeah, quote surveys, deploy them, collect your data, and then up next you want to clean your data. Now, I want to say that this step is more like one of the I don't want to say biggest now, but it's one of like the major steps in data analysis. Because in most cases, the data would never be clean. Data would never come clean, and you have to clean data. And what do I mean by clean data? Like cleaning your data. Now, when we say clean data, we're talking about removing or correcting errors and inconsistency from the data set that dealing with essentially you're doing data wrangling, like um trying to remove empty data points, null, all of those things. Probably we'll talk more about that when we are facing them or we are having a clean data session, like data cleaning session rather. Right, so up next, after cleaning your data, you want to explore the data. And that is abbreviated as EDA, which I think is exploratory data analysis, I believe. And well, depending on you and well, depending on you and probably the kind of data you're working with, could match this step with analyze data step. But ideally, when you are exploring the data, you want to understand trends in the data set. You want to understand if there you want to spot and understand outliers. Like I said, outliers are extremely large or small values. For instance, um, let's say, okay, let's just stick with this crop yield and rain, for example. So let's say while after collecting that data, I noticed that um the the data point for crop yield has a very, very low um crop yield. Like I could feel like why did this happen? And maybe ask the people who were on the field, or just do more investigation to see why that happened. So those are the kind of things you do in in exploring your data. You want to understand outliers and why. Possibly there was faulty equipment, like missing value. Why was it missing? Maybe the person forgot. Maybe the like, okay, I said it already. The equipment was faulty and they could not take measurement observation for that day or that time frame, or it was taken but not recorded, or blah. It could be several issues, but you want to look into those things. You want to check trends. You want to see if there is, well, depending on the kind of analysis you are doing, but you want to do stuff like, is there correlation between this variable and this, and all of those things. All right. And yeah, you also want to like study patterns or notice pattern within variables. So up next, you want to explore your data. This is where you do your do, right? You do what you need to do. So you apply the statistical techniques or models that you want to. So after that, you want to proceed to visualizing and communication. So you use charts and dashboards to communicate to put visuals, to present visuals actually, and communicate your findings to your employee or the end user basically. And lastly, remember the end goal of data analysis is to make um insights from data. So after the whole thing, after collecting, defining, collecting, cleaning, exploring, analyzing visuals and all, you want to be able to turn your insight into actions. You want to bring your findings to your maybe stakeholder or the end user, and so that they'll be able to make informed decisions from that findings or insights. All right, I think this is the last thing we'll be talking about now, and that is storytelling with data. Now, what is storytelling with data? Well, storytelling with data, it combines visuals and narratives to communicate insights. Why does it matter? Well, the idea is that it helps decision makers to understand the why, and it also engages audience even more effectively. Like I was talking about the other time, sometimes people don't just want to see numbers. They're not interested. Like they've been seeing numbers all their life. So numbers do not like excite some people. So when they see charts and you bringing a creative story, you know, coming up in a creative way, presenting your data with a creative story, then it will be appreciated. All right. So, what are the elements or key elements in telling stories with data? So, first off, you need your narrative. That's the storyline of your data. You want to find a story that you're attaching the data set to or the data to. Then the next thing is you want to find visuals, which are your graphs, your charts to support the story. You want to find any visuals, your visuals basically. to support your story, to buttress your point, or maybe to make you realize that your claim was wrong, depending on the situation. And after that, you need data, right? You need accurate and relevant information. You don't just want to base your storytelling on false data, right? Because your conclusion will be false. And what is the whole point? So you want to make sure that the data set you are relying on or using is accurate and relevant. All right, so here's an example of telling a story with data. Now, this example says that telling the story of why student performance improved over time using attendance, study hours, and test score. I'm tempted to say that this would be like as probably one of the tests. Okay, maybe I should say that it would go one of the tests. So you just want to find a story around it. And here you just have to be creative. Find a story, then explore the data. Now use the data, the findings to back up your story. And after all, you present the whole thing. But remember, it has to be a trusted and relevant data set. All right. So recap, just to summarize what we've talked about so far. So we talked about data, talked about we defined data, what it means. We talked about types. We said data comes in many forms and serves many purposes, right? Then we also talked about understanding types of data is foundational, right? So it is very important to know the types of data. Then descriptive statistics help to summarize information. That's just what it does. See it as narrating, like um you you want to narrate a story, right? Or you want to, okay, just as the name says, descriptive. My one of my lecturers would say, imagine that you want to, okay, you're looking at the person and you want to describe that person. Start by saying, okay, for instance, he has big head, dark eyes. You are describing the person. So that is actually what you are doing when you are talking about descriptive statistics. You are describing the data, if that makes sense to you. Then also we talked about visualization. Visualization brings clarity. That's very important. Visualization brings clarity. Most times, stick with simple and yeah, and clear. Simple and clear. Just make it simple and clear. And we say a proper workflow ensures good analysis. Yeah, so the the flow is continuous. Sometimes you need to um get here and go back to the previous step, or probably when we are doing a project, would be able to um walk through the data analysis workflow ourselves, and we'll be able to see what we mean. But again, a proper workflow ensures good analysis. It just makes you, at least you know what you are doing. You don't feel lost at any point or unaware, like you're just caught off guard and all of that. So well, it could be modified, like I was trying to say that exploratory data analysis could be matched with analyze the data the other time. So just find what works for you. But ideally, you still have to touch most all of those points ideally, basically. Then lastly, we say that storytelling adds meaning to numbers. Woo, I love that. Storytelling adds meaning to numbers. So don't just pull numbers out there. And I think I learned this from one of my mentors also, one of the people I look up to. So most times you don't just present your findings, like present numbers and all. Try and find a story around it. Oh, you're talking about education. Think the story. Just be creative. I know sometimes it does not come easy, but just be creative. Think and connect it to something, and to be amazing, really. All right, so we are done. Done. So um the the because of time, I will just make sure that if you have any questions, you can just ask on the group. Um for now, that would don't take um more time, more time. Further readings and resources. Well, I I I would share this in the group also. I would um I would I would I would collate or compile some sources you could look into if you want to really dive deep into these things and maybe read ahead or like just like read up on your own. So I'll share this in the group also. All right, so if you are still there, please scan the QR code. Is just the two questions survey. Scan the QR code and answer the questions honestly. Just two questions. It won't take you um it won't take you 1 minute fast. But obviously, like it's not a lot. You don't even have to type. You just have to pick from the option. All right, so thank you very much for joining. My name is Omani Taiwo. See you in the future.